question where most students really get confused because they end up working out stuff that you don't even need to work out because it is asking you for the ratio, and then they really get confused because they've already given you the pH. They haven't given you the Ka, but with the stuff that they've given you, you can work out the Ka, but they're asking you for the ratio. They're not asking you for the Ka. This is 5 marks, so which basically means it can cost you half a grade. So it's really important to be on top of these maths questions because in chemistry, especially in chemistry, maths, the maths questions have a lot of marks. Even the 1 markers make a huge difference. So it's really, really super important that you need to get on top of these sort of questions. In chemistry, of course, the theory behind chemistry is really important as well, but these kind of questions are where students really lose a lot of marks. So anyways, so they've already given you what you need to have in order to work out what they're asking you. Okay, so you've got the pH of healthy blood, and they've given you the ratio of the hydrogen carbonate to carbonic acid ratio, and they've also given you the patient's blood is measured at 7.7. So obviously, quickly highlight the stuff that they've already given you. Okay, so they've given you sort of 3 different set of values, which is super important into working out the actual ratio, which is the actual question itself. That makes sense. Okay, so let's work with the blood at 7.4. So first things first, okay, they've given you the pH. In chemistry, always link back to what you already know. So they've already given you the pH. Fine, that's fantastic. But what else you can do with pH is you can work out the concentration of the H+. That's pretty self-explanatory because the formula for the H+ concentration is 10 to the power of minus pH, okay? So in this case, it's going to be 10 to the power of minus 7.4. And this should give you an answer of 3.98 times 10 to the power of minus 8. Using a calculator, it's pretty self-explanatory. Okay, then they've given you the ratios for the hydrogen carbonate and carbonic acid. Now, most students really sort of panic here because they haven't given you actual concentrations. They've just given you a ratio. Always work with what you've already got, okay? So they've given you the H+, that's perfect. But, so say if I was to work out the Ka of the healthy blood. So the Ka of healthy blood would be H+, okay, HCO3 minus over H2CO3. Okay, that's that. So they've given you the H, we worked out the H+. They've given you the ratio for the hydrogen carbonate, which is here, and they've given you the carbonic acid. So essentially, you've got everything already to work out what Ka is. So just plug in all the numbers as it were. So 3.98 times 10 to the power minus 8, okay, times that by 10.5, I believe, yeah. So 10.5 was the ratio, which was the ratio there, and then all divide by 1. This would give you an actual answer of 4.18 times 10 to the power of minus 7. But what did we exactly work out here? It was the Ka. Okay, that's amazing. We've worked out what the Ka of 7.4 is. Still, we haven't got the actual answer, but we're getting there. So now let's move on to the second set of information they've given you, and they've given you the pH of 7.2 there. So 7.2 goes there. Let's work out what the H+ concentration is at this particular pH. So it'll be H+ over 10 to the power of minus 7.2. This would give you an actual answer of, using a calculator, make my life so much easier, 6.31 times 10 to the power of minus 8. Yeah. So, that's that. Again, that's not the answer. We're getting there. All right. Now, what are they actually asking you? So, worked out the Ka, you worked out the H+ concentration of both blood samples. Now, they're asking you for the hydrogen carbonate to carbonic acid ratio in the patient's blood. Now, what this means Okay, so let's go back to the Ka expression. What they're asking you, actually, let me just write it separately here. So Ka, okay, is equal to H plus HCO3 minus over H2CO3. Okay? Now, they're asking you the hydrogen carbonate to carbonic acid ratio. So, think about it logically. You've got this formula. What can you do? You've got the Ka, you've got the H plus, okay? Because remember, we need, the patient's blood is now measured at 7.20. So forget about the 7.40. That's just a healthy blood generally. But we're talking about the specific patient, which basically means that the ratio of the hydrogen carbonate to carbonic acid would be something really similar to the Ka over H plus, okay, of HCO3 minus over H2CO3. Think about it. Hydrogen carbonate to carbonic acid ratio is the same as the Ka to the H plus ratio. So you don't have the values of these ones, but you do have the values of this one and this one because you just work them out. That's going to give you the same number or the same ratio as the hydrogen carbonate to carbonic acid ratio, which basically means you got 4.18 times 10 to the power minus 7 over 6, oh god, that's really bad, 6.31 times 10 to the power minus 8. That's your ratio. Obviously, using a calculator, you can easily work that. That would be 6.6, and this would be 1. So, in reality, the answer is actually 6.6 to the ratio of 1. So that's your hydrogen carbonate to carbonic acid ratio, 6.6 to 1. That's your ratio. In other words, you can just sort of write here, that's your hydrogen carbonate to carbonic acid, which is H2CO3. And that's your answer. If you think about it, all you needed to do was work out what Ka was, and then essentially what H plus was, and then just plug them into this expression here that we made. But that's where you have to sort of think about the chemistry involved as well, because yes, we used the formulas, but remember, they're not asking you to work out the, I don't know, I remember doing this question back a few years back, and I remember my friends, they were working out the Ka, and I think some of them worked out even Kw, which made no sense because it's not asking you for anything else except from the ratio. And that's where loads of students get confused, because it's not asking you to work out anything other than the ratio. And plug in a few numbers in just straightforward formulas that you already know, okay, you already got the answer, and that's your 5 marks gone. Well, your 5 marks added to whatever you've got on your paper.